Hey guys, welcome back to Bioinformatics with R. In this video, what we're going to be doing is we're going to be creating karyotypes or plots of chromosomes where we take SNP data that we're randomly generating, but you could take real SNP data if you had real SNP data and plot it onto those chromosomes. So you can kind of get a visualization of where these SNPs rely into each other, or rely in reference to each other, or just in reference to the genome or the chromosomes as a whole. So without further ado, let's get into it. Okay, so like always, first let's load the required packages. We're going to use two packages for this one, KaryoploteR, and we're going to get a lot of work out of genomic ranges. All right, so now we need to set up the genome object for our karyotype. And we're going to create our genome object. So our genome data frame is going to be a data frame, obviously, where I'm going to put a note in here. First, we dictate the number of chromosomes. So we're going to say CHR for chromosome equals paste CHR. And then 1 through 5. So we're going to do 5 chromosomes. This could be like a Arabidopsis, which has 5 chromosomes. Start is going to be nucleotide 1, and we're going to do that for all 5 chromosomes. And then we will dictate the length of each chromosome. So our end is going to be 349,64571 for the chromosome 1, 220,37565 for number 2, 254,99034 for 3, 208,62711 for 4, and 312,70811 for 5. Okay, let's run this. All right, so we have our G ranges object. There's an unexpected comma here. Okay, let's run it again. All right, so as you can see here, we have our chromosomes 1 through 5. We have our start position, which is nucleotide 1 for each chromosome, and then our end position, which is the length of the last nucleotide from position 1. So now we can convert data frame to a GRanges object. So for our karyotype stuff, we need things formatted in a GRanges object. So this is where we'll be using a lot of GRanges package. So we'll say genome GR for GRanges is make GRanges from data frame, and then we'll just give it our data frame, which is genome data frame. So this simply just converts that data frame into GRanges object. Now let's create some SNP positions to map out. We do this by using the sample function. So we're just going to randomly create some SNPs. So our SNP position is going to be a sample, and we're going to say between sample a number between 1 and 1 to the 7th, and we're going to do this 25 times. And then we're going to create a data frame out of this, where CHR, our chromosome, is going to be CHR, and our sample, and then replace equals true. So if we rerun this a second time, it'll just replace and not keep both sets of our random SNPs. So our start's going to equal our SNP position, and our end is going to equal our SNP position. So the reason that we do the start and the end for this data frame. Post 0, paste 0. Snip. Did I not run this? I gotta run both of those. Okay, there we go. So our snips here. So state and end, I should read. Let me fix that real quick. Start and end. Okay, so the reason we put start and end is because when we want to map those snip positions, the granges object is going to say, all right, what's the start and end for this thing that I'm mapping? And since it's a SNP, single nucleotide polymorphism as opposed to like, indels, I guess, are still SNPs, but instead of like a transposable element or a microsatellite or some other mobile DNA element, it's just going to be one position that changes, right? So we don't want that mapping of it to be a big long range of positions. Okay, again, we convert the data frame to granges, right? So karyotype R is going to want a granges object, and we have a data frame, so we have to make granges from data frame. Oh, make sure you don't pick list. I did that before and it messed up. So granges from data frame. And then we're going to use snips. What do we do? Snips, right? Yeah, snips. Okay, so now we have a granges object. Great. Now let's create some SNP labels. So if we look at our SNPs, our data frame, we don't have labels, right? We just have line numbers. So we're going to make some labels for them. So when I graph, it's a little easier to read. So our SNP labels are just going to be SNP underscore and then the line number, essentially, right? Just so we can kind of see a little bit better than just numbers being there. Let's run that. Okay. So here we will set the margins for our plot. So first thing we're going to do is we're going to look at the plot parameters. The default plot parameters for plot type 1. So this, if you ever want to look at what your parameters are before you change them, you can look and see like what the value is for the left margin, right margin, things like that. Without spending too much time with you exploring it, I'll kind of give you what worked best for me. Set the margins of our plot, plot params, and we're going to say, we're going to do plot params $, and we're going to say data 1 out margin at the bottom there. We're going to set that to 600. And that should allow us to have our labels fit within the graph. And now let's plot it. Now let's plot our SNPs. So KP is plot karyotype, and the genome that we're going to use is our genome granges object. Our plot type is equal to 1. Our plot params equals plot.params. And then KP plot, we want to plot markers. So you can see there's a whole bunch of different things that you can plot with the karyoplot thing, but we're going to pick markers, and we're going to add that to our KP plot that we just made above. And we're going to use snips gr, so you can see here, as our markers, and the labels for those markers are SNP labels. Okay, so let's run these two. First, we're going to create our karyotype. You can see we have just the chromosome information. The second one adds markers to it. So you can see these are all of our SNPs that we created and where they are located on each genome. You can see that instead of having just numbers, we added the snip underscore before them, so you can identify what you're pointing out. Okay, so cool, but we can add a little bit more to this. So let's we can also add some numeric data to our plots. We will generate 100 random numbers that plot to 100 windows on chromosome 4. Okay, so we're going to create some numeric data and put it in a data frame. And we're going to say y, which is just where we're storing the random numbers, is our norm. So take random numbers from a normal distribution, and we're going to take 100 numbers. We're going to make the mean of our sample, so of all the numbers that we randomly generate, we're going to make the average of that 1. And our standard deviation of this sample is going to be 0, or 0.5. And then we're going to, for chromosome 4, break it up into 100 windows. And the start equals 1 through 208627771, and then 208627711 divided by 100, and the end is 1. The end is just the same, so I'm just going to copy and paste it so I don't get transpose any numbers or anything like that. Okay. Okay. I have no idea what. I spent some time trying to fix that, and I just retyped it and it worked. So I don't know where my typo was. I'm sure there was one. But if you type this code in right here, it should work for you. All right, so we have our numeric ranges. Now let's make the ranges our numeric data. The data a granges object. So we do numeric data granges is make granges from data frame. Numeric data. So we're converting that. Cool. Again, let's set our plot parameters. So plot params, remember if you want to look at them, is just to get default plot params. And we'll look at plot type equals 2. So our plot params, you can look if you see what you want to adjust. Let's do plot params $data1 out margins is we're going to set that to 800. Plot params. Oh no, need a 2 out margin. We're going to set that to 800. Plot params, and then our top margin we're going to set to 800. So let's run all this stuff. And now let's plot. So for the plotting, the first thing I'm going to do, I'm just going to take this plot code that we had above as kind of a shortcut because we're running the same, those two facets the same. There's two facets, I guess, or plot layers. But we're going to add a third line. So KP lines. So we did our plot, and then we added the markers. And now lines, we're going to add to KP numeric data gr that we created. Y equals numeric data $y data panel equals 2. Okay, so now if we run this, you can see that we have added this line graph to chromosome 4. Let's do data panel equals 1 and see what happens there. Nothing. That doesn't change it. So yeah, so you can see it kind of goes over top of our SNPs. Let's change this to plot type 2. Let's see what happens. There we go. That looks a lot better. So you can see we have our line graph now underneath here, where we have whatever numbers we randomly generated across 100 different windows for chromosome 4. But like if you had read coverage or something, some sort of quantitative information across the genome, you could plot that in addition to your SNPs. So it's always nice to create, have a product at the end of one of these, so it's nice to have kind of a picture of a genome with SNPs on it. But that's how you plot SNPs. You could do other markers as well if you wanted to do RFLP or microsatellites or mini satellites or anything of that nature, methylation sites. You could all do this with KaryoploteR to plot across your genome. Just kind of get a step back view of the whole genome and the chromosomes and how these features on the genome relate to one another spatially. So without going on too much, that's all I got for this video. I hope you enjoyed it, and I will catch you in the next one.